Hello and welcome back to my channel. If you haven't subscribed, please do subscribe. In this video, we are going to talk about um, writing LP formulation for the maximum independent set problem using this example. We have talked about how to do this formulation in previous video. Please, if you haven't seen it, you can just go see it. So as usual, we label first. I like to use x's. So you have x here, x, x, x. So each vertex now will be called a new variable. For each vertex, we have x sub v1, v1. This is for vertex 1, x sub v2 for vertex 2. And this would be either 1 or 0, 1 if chosen and 0 if not. Having said that, let's define our goal. For a maximum independent set, our goal is to find a maximum sized subset of the vertices. Maximum sized subset of the vertices, right? Subset of vertices such that for each edge uv, at most one of u and v is in this subset of vertices. I hope that makes sense. So next thing, we define our objective function. Based on the goal, that means our objective function is going to be max xv1 plus xv2 plus xv3 up till the last vertex. We can also just write that as xv sub I, where I goes from 1 to 7. This is number 7. Okay, next we define our constraint. Now, our first constraint is that each vertex is either chosen or not. That is, it either has the value 1 or 0. Our next constraint will be based on the relationship as seen in this diagram. So, x1 connects to xv1 connects to xv2 and xv4. So this means that xv1 plus xv2 will be less than or equals 1. xv1 plus xv4 will be less than or equals 1. Then we move to xv2. xv2 connects to xv1, right? No, xv2 connects to, yes, xv1, xv3, and xv4. So you can say xv2 plus xv3 less than or equals 1. And you're going to continue, just like in the last video I explained, you're going to continue up till xv7. So for xv7, you're going to continue in this way for all connections. So as I've written xv2 plus xv3 less than or equals 1, you still have this xv2 plus xv1, you still have xv2 plus xv4, and you're going to continue expressing these relationships as linear inequalities until you get to the last one. And the last one would be xv7 plus xv5 less than or equals 1. And then let's say xv7 plus xv6 less than or equals 1. So the next thing you do is to enter all these values. Let's see. So we want to, the first thing you notice is that this is a hard problem because x is either 0 or 1, right? And that means you can relax it. And when you relax it, you have, so as an indication to know, since we are solving with LP and an online LP solver that can solve both hard problems and relaxed problems, I think you should look out for an indication whether to relax or not in your question. This question is asking whether this is fractional, so it means we can relax it. But some questions would ask you to solve it as integer problem. So for questions that ask you to solve as integer problems, you do not have to relax it. So when we relax this, x is between 0 and 1. And when you enter all of these relationships in an online LP solver, you're gonna get something that looks like this. X v1 equals 0.5, something that looks like this. X v2 equals 0.5. So you're gonna get values for all of the edges. That's what I'm trying to say, and they're going to look like fraction because you have relaxed this. This video is going to end here. And for the last question, is it fractional? Yes, it is fractional. We're going to end this video here. If you haven't subscribed, please do subscribe. And I'll see you in my next videos.